In this video, we're going to talk about parts of similar triangles and how those parts are also proportional in the same way that the sides are. So we'll start with medians, okay? So we've got triangle ABC is similar to XYZ. Right here we've got our similarity statement written out. Triangle ABC is similar to triangle XYZ. And so when we talk about two triangles being similar, what that means is that all the sides, and say the smaller one, ABC, all the side lengths can be multiplied by the same number called the scale factor to scale them all up to these lengths. So there's always a constant multiplier. Or vice versa, we could start with these longer sides on XYZ, multiply them all by the same scale factor, which would be a fraction, to shrink them down to these sides ABC, but there's that constant multiplier. And once you find that, you can find the lengths of these medians, how they're related as well. I know that these are medians because I can see that the segment comes from B across to side AC and splits it in half. Same thing over here. We have the segment from Y coming across and splitting segment XC in half. So we have medians. So let's say we had some numbers in here. Let's say that this guy is 5 units long here. And let's say that we know its median is 7 units long in here. And let's say we know that side XY has a length of 9. And we want to know the length of that median in the larger triangle. Well, just like any other similarity problem, we can set up a proportion to solve. Okay, and you can set it up a lot of ways. What I like to think about is I like to find these sides that correspond in the triangles and set those up in a fraction. So I have 5 over 9, and that's equal to another fraction here. Okay, and so if I put 5 over 9, the other lengths that I'm using in this are 7 and x, and I need to put them in the fraction the same way. So since I put 5 on top of the left fraction, I need to put 7 on top of the right-hand fraction. And since I put 9 on the bottom, I need to put the side from that same triangle on the bottom of my other one. So the trick in these is to set these fractions up the right way. Once you get it set up, it's nearly impossible to miss it at this point. All right, so if you remember now, the way to solve a proportion is you cross multiply. So we multiply 9 times 7, it's 63. And that's equal to 5 times x. Then we just do a quick division. 63 divided by 5 to solve that for x. Okay, and so we get x equals 12.6 is what that ends up being. So 12.6 units. So that's how long our median is. It's always a good idea to do a quick check. We definitely need to get something bigger than 7 because it's a bigger triangle. We did. We got 12.6. So if you do it in the wrong order, you're probably going to get something smaller. So watch out for that. So that's medians, okay? And that same relationship, the same trick holds for these segments too. And so these segments, they drop from a corner of a triangle to the other side and form a 90-degree angle in both of them. So those are called altitudes when you have that. So this is altitudes, and they work the same way, actually. So it's really nice. Let's put some numbers in here. So let's say that side's 3. Let's say this is like 5. And this time I'll give you the larger altitude. So there's a 6. Okay, and so what we want to find is like how tall is this thing? What is that altitude in there? We'll call it x. Okay, and so we just want to set up a proportion again. So we'll do it the same way. I'm going to take corresponding sides from each triangle, 3 and 5, and I'm going to write them in a fraction. And then I'm going to take these other pieces, the altitudes, and put them in a fraction in the same way. So since I did 3 over 5, the small one over the big one, I've got to do x over 6 for my other one. Just got to make sure I get it straight. And then it's just a matter of cross multiplying and dividing. So multiply 3 times 6, we get 18. Multiply 5 times x. And we divide by 5 again. So divide by 5 on both sides. And so 18 divided by 5 is 3.6 units, okay? So what a lot of people will do, a place people will go wrong in these kind of similarity problems is they'll just say, well, oh, this altitude's 1 bigger than this side. So I guess this thing's 4, it's 1 bigger than this side. But that's using addition, and we never want to use addition or subtraction when we're talking about similar figures. We always have to scale using multiplication. So don't get tricked into that. Don't say, well, if this is 1 longer, this is 1 longer. It's not true. You can see that we came up with something a little bit shorter than 4 for that. So be careful. In this triangle, we have an angle bisector drawn. So I know that this segment is bisecting this angle because of those congruent marks. So that side is the same as that side, so it's cut in half. Now, when you have an angle bisector, we get some interesting relationships here that can work nicely in finding missing side lengths, okay? So the relationship you have here is if I call this length x, say that side has a length of x, And let's say that side has a length of y. So these two sides that make the angle being bisected. One's x, one's y. And let's say that this little section down here is A, and this little section down here is labeled B. Well, it just so happens that these are in proportion to each other in such a way that x over y is going to be the same thing as A over B. And so that lets us find missing sides when we do that, okay? So let's put some numbers in there. Let's say we knew that instead of x, we had an 8 over here. And let's say instead of y, let's say y is 12. And let's say we know that A down here is 3. And I want to find what B is. Okay, well, because I have this angle bisector, I can set up that proportion x over y equals A over B. Okay, the two sides that make the angle are equal to these two pieces in a fraction. Okay, so x over y, let's do 8 over 12. And that's going to be equal to this piece, 3 over whatever B is. 3 over B, just like that. Okay, and so to solve a proportion, remember we cross multiply. So 12 times 3 is 36. Over here we've got 8 times B. Now I'm just going to divide by 8. So divide by 8, divide by 8. And B is going to equal 4.5. Okay, so B is 4.5 units. In this triangle, we have another segment running through it right here so that it's parallel to one side of the triangle. So you can tell they're parallel, remember, by these little arrow marks. Okay, now when this happens, it splits the sides of the triangle into proportional pieces. So if I call this little piece A, and I call this little piece over here B, right, A is from the tip to here, and B is from the tip to here, and I call this piece C from this parallel to this parallel line, and I call this D over here from this parallel line to this parallel line, well, we can write a proportion. We can say that A over B is equal to C over D. So it splits these up into proportional pieces. And so we can use that information to solve for missing parts. Okay, so let's replace those with numbers. So in this triangle, I have a parallel segment to the bottom running right through the middle. It cuts this side into a piece of 2 units and 4 units, and it cuts this side into a piece of 3 units and x units. And so all we have to do is just set up a proportion to do this, okay? So this piece, that's sort of two top pieces of this little triangle that's chopped off the top here, these two sides, 2 and 3, we can put those in a fraction. And then we can take the other pieces, sort of the stuff between the two parallel lines, the 4 and the x, and put those in a fraction like that. And so then we have a proportion to solve, okay? So the easiest way to solve a proportion is to cross multiply and divide. So we do 4 times 3, 12, and that's going to be equal to 2 times x. And so we're left with 12 equals 2x, divide by 2 on both sides, and we see that x is 6 for that little piece. So we know that this guy is 6 units long. And we can tell that, I mean, we could probably almost do this one with these small numbers in our head. Another way to think about it is this little piece of 2 doubles to this length of 4, and so this little piece of 3 doubles to this length of 6. So everything is scaling up with multiplication in these. Okay, the way that we can make these a little more challenging is to give you these pieces, to find the lengths of the parallel lines. You have to kind of watch out for this one, okay? So for this one, what we're going to be tempted to do is go, oh, okay, well, 5 over 8 is x over 12. And that's not actually true, okay? We have to be a little bit careful. What you want to do on this one is, because 5 and x are part of this little triangle here, we can put those in a fraction. So I'm just going to go 5 over x here. So sort of the left side over the bottom of this little triangle. Now, when I do that, I have to put the left side over the bottom of the larger triangle. Well, we can clearly see that the bottom of the larger triangle is 12, so that matches up here. But what we have to watch out for is we have to consider this entire side like this. So we got to think about 5 and 8 together. So that side's going to be 13 that goes in there, okay? So we're talking about this whole side of the small triangle over the bottom is equal to this whole side of the big triangle over the bottom. So we got to be careful on these. But once we get it set up, no problem. Easy to cross multiply and divide, right? We can do 5 times 12 gives us 60. 13 times x, 13x. And then just divide by 13. And so we get x equals, that's 4.62